I have the honor of introducing a fellow Minnesotan here, Mr. Vance Fiegel. He's a cell and microbiologist and an entrepreneur. He studied at the University of Minnesota, go Gophers, and has studied basic biology and inflammation and wound healing. So he co-founded Embryo Corporation and also Creative Water Solutions. He has published over 60 articles, and he has 26 patents. I have one, and I know how hard that is, so I'm overly impressed there. So if you can help me in welcoming Mr. Vance Fiegel.
Well, thank you for that wonderful introduction. I'm very happy to be here and like to thank the organizers for the opportunity to discuss some of the things that we've done. We are in a natural technology session, and I will be talking about our Sphagnum moss product in terms of how it can affect disinfection byproducts. But I'm also going to talk a little bit about disinfection byproducts, the organic contamination that is the substrate for disinfection byproducts. And then I will talk a little bit about sphagnum moss, and then I will also be talking about some results we've got using sphagnum moss and how it can reduce disinfection byproducts in commercial pools. All of this data that I'm showing today, I don't think it says on the slides, is on using indoor pools, and also it's all on commercial pools of various sizes, and I'll try to give you a little bit more of the pedigree of those pools when I get to that part of the discussion. See if I can figure out which one of these moves the slides. There we go. Disinfection byproducts. I think we've all been exposed to those quite a bit here at this conference over the last few years, and in swimming pools, I'm sure, too. But Peter Blatchley, I know, has another discussion tomorrow. He'll be talking mostly about the nitrogen-containing disinfection byproducts. My discussion today will be mostly about trihalomethanes, which are the carbon compounds and the disinfection byproducts that come from carbon compounds. As we all know, I think by now that disinfection byproducts come from the reaction of primarily chlorine, since we're talking about commercial pools, as they oxidize organic compounds. This oxidation of organic compounds results in disinfection byproduct formation. Ultimate oxidation actually takes it down to one carbon compound, such as chloroform. There's a number of disinfection byproducts, as I mentioned. There's the chloramines and the trichloramines, which are the nitrogen-containing compounds. The trihalomethanes, which I will be talking about today, which are the primarily carbon-containing compounds. And then I'd like to also point out, and the slide didn't come out very well, that some of these compounds are both volatile and some of the other ones are non-volatile. And that's an important concept, because the volatile ones actually move from the water phase into the air phase and become more of a problem, obviously, in indoor pools, although I think people need to recognize that even in outdoor pools, as those compounds volatilize, there is a fairly high concentration right at the air-water interface. Organic contamination. Well, as I mentioned earlier, this is an important component because it's the reaction of the chlorine with organic contamination that creates these disinfection byproducts. And I like to look at disinfection or organic contamination as being in two phases. One is the waterborne disinfection, or the waterborne organic compounds. These would be the lotions, oils, sweat, perspiration, urine, things of that nature that are soluble in water. And then there's also the surface organic contamination, which is present on the surface of the pool, but primarily, as I'm going to show some information in this discussion, that's of the sand filters and the pool filtration units are the primary source of surface organic contamination. The waterborne organic contamination includes things like cells, hair, feces, leaves, bathers, leaves in the outdoor pools anyway. These are the insoluble sorts of things that are organic contamination. And then you also have the soluble organic contamination, which is the urine, sweat, lotions. Whatever comes in with the source water, so at certain times of the year in certain parts of the country, there's fairly high organic loads in the water as it comes in from the source. Surface organic contamination includes biofilm, which I think we're all getting more and more familiar with, but also a lot of things actually adhere to surfaces that are not biofilm. The biofilm people call this kind of a conditioning film. So your lotions, anything, DNA, proteins, things of that nature can also coat surfaces. So they're not actually soluble, but they're actually on the surface of the pools, surface of the filters. Within the biofilm component, you've got the bacteria, the microbes, and protozoans, and potentially the parasites such as crypto. Also, part of the conditioning biofilm and part of the biofilm is the extracellular matrix that the actual bacteria actually make. So there's a lot of protein, polysaccharides, DNA, a lot of organic material that's actually bound to the surfaces of the swimming pool. Again, especially in the filter systems, where there's a lot of surface area and probably not very even flow throughout the system and equal decontamination by the chlorine throughout the sand filters. This is just a kind of a schematic of what all can go on the surfaces. So this is actually a slide from the Center for Biofilm Engineering at Montana State. I have to give them credit for that. And it goes beyond a little bit of what we're talking about here, but it shows all the sorts of things that go on at surfaces. Biofilm causes corrosion. You've got particulates within the surface material. That can be hair, cells, different things of that nature, whatever comes through that is not picked up by the filter. Within the filter, you've got all kinds of particulates that will be incorporated into the surface of the sand. Scale is another factor that causes adherence of biofilm and things of that nature. And then you've got detachment of this material also, which then it moves into the liquid phase of the pool until it gets filtered back out again. I guess the one thing I didn't point out here is that this kind of makes the surfaces kind of a reactor. You've got lots of things going on, both biologic and organic chemistry-wise, that are going on at the surfaces to create all these disinfection byproducts. Organic load and pool filters. Pool filters are a major repository of organic material. That's part of their job, is to catch everything that comes through. So they catch all the organic material that they can filter, such as cells and hair and things of that nature. But because of what we know now about biofilm and things of that nature, there's a lot of actual growth of organic matter upon the sand in a sand filter. Even we've done experiments in our laboratory where we've taken clean out of the bag sort of sand, and actually it already has some organic contamination present on the sand as it comes out of the bag. As we know, if we see really dirty sand filters, the combination of the organic load and the sand can actually create kind of a sandstone within the filter, which makes the filters very ineffective. As the particles get bigger and bigger, the filtration efficiency goes down and down. Again, in our laboratory, and I'm not going to go into this today, we've done a lot of work looking at sand filters and the material that's contained upon them. And one of the things that we've done is look at the effectiveness of backwashing in terms of removing all the organic load, and we found that backwashing alone is not very effective at removing the organic load. In fact, it only removes 30 to 50% of the organic material on a sand filter. And even if you backwash numerous times, that seems to maximize at about 50%. So even when you backwash efficiently, you're still not removing the majority of the organic material from the sand media. Switching gears here a little bit, I'm going to talk about disinfection byproducts and are they a health problem. We know from the chemical nature of a number of the disinfection byproducts that they have no toxicity for humans. As I mentioned earlier, many of them are volatile, so they're absorbed through the lungs. But many, again, are also absorbed, especially the ketone sorts of disinfection byproducts, through the skin. So even though you may have good circulation, even though you might be in an outdoor pool, there's still absorption of disinfection byproducts through the skin. I'm not going to go into a lot of detail. I'm sure we've all seen a number of the studies that relate disinfection byproducts to reactive airway diseases and precursor diseases. There's been a number of studies more recently coming out that's showing that competitive swimmers, especially people who spend a lot of time in the pool, have much, much higher incidence of early stage reactive airway disease sort of markers. And other studies have actually even shown that bladder cells can go through epigenetic changes from people that have increased exposure to in swimming pools and increased exposure to disinfection byproducts. So I think while the jury is out a little bit in terms of direct correlation, there's been a lot of work that would seem to indicate that constant exposure to disinfection byproducts from exposure in swimming pools definitely has some health effects, and that, again, more and more research is coming out that decreasing the disinfection byproducts is an important goal. I'll talk a little bit now about sphagnum moss. Sphagnum moss is a product, I'll talk a little bit about the basic biology of sphagnum moss. It's a plant that grows in bogs and wet, cool climates. When it's dried, it absorbs about 20 times its weight in water. It's been used for ages in horticulture. In World War I, it actually had been used as a wound dressing, again, because it was so absorptive. And it's also been used in feminine pads for that same reason. And it's been used to treat wastewater because of its high cation exchange capacity. It binds both mono and divalent cations primarily. The previous discussion here talked a little bit about limnology, and being microbiologists and cell biologists and not field biologists, we looked at it maybe a little too simply, but northern Minnesota, which I'll show on the next slide, is full of sphagnum moss bogs. It is also full of some of the most beautiful lakes in the United States up in the Boundary Waters Canoe area. And we kind of put one and one together and thought, well, maybe one of the reasons that water looks so good, and it partly is true, is that because of the sphagnum moss bogs. If you look here, I don't know if you can see that. It's a little hard to see. This whole area of northern Minnesota up here is full of sphagnum moss bogs. And so when we first started looking at this product, as was indicated, we have background in wound healing. We ran across some articles from World War I that said that sphagnum moss inhibited or was made into wound dressings, that actually the soldiers that had their wounds treated with sphagnum moss had higher survival rates than the soldiers that got regular cotton dressings. And they attributed that to the fact that sphagnum moss is absorptive, and that's probably part of the reason. But we also hypothesized that there was something else going on. So we started to look at sphagnum moss potentially for its antimicrobial activities, which it has some. But when we tried it in swimming pools and spas, we recognized that the antimicrobial activity was not cidal. It didn't kill anything. It actually just kind of inhibits bacteria from growing. So it's more of a bacteriostatic compounds rather than bactericidal. So we realized we wouldn't be able to replace chlorine with that. But in the process of those studies, we discovered that it has lots of other unique features in swimming pools and spas. So over the years, we've used this in spas for the longest period of time. It's only been in the last 3 years or so that we've started to use it in commercial pools. But we know it does these things both from, some of this is laboratory data and some of this is from field studies in swimming pools. We know it absorbs cations. And in swimming pools, that's important because it removes calcium, which inhibits the ability of scale formation. We've done that also in the laboratory. We've made scale, and we can actually pull scale back into solution using sphagnum moss. And it actually will inhibit that scale formation in the laboratory as well. We know over the years from both lab studies and from field studies that sphagnum moss reduces the organic contamination in swimming pools. As I'm going to show you, it reduces disinfection byproducts. It stabilizes pool chemistry, stabilizes pH, stabilizes the chlorine levels. It actually reduces chemical usage in a number of ways. It makes it possible to reduce the use of some chemicals in totality we don't need as clarifiers. It reduces the amount of pH adjustment chemicals that are used because the pH is much more stable. And in many pools, it reduces the chlorine demand so much that you use about half the amount of chlorine that you typically use without sphagnum moss present. And then from some work that we've done more recently in cooling towers, we actually know that sphagnum moss inhibits corrosion. We can remove the corrosion inhibitors from cooling towers and replace it with sphagnum moss and still have the same level of corrosion inhibition. So what are the benefits of using sphagnum moss in swimming pools? Is improved water quality. That includes aesthetic things like water clarity. We stabilize the pH and the chlorine levels. Reduces scale and staining, and reduces corrosion. And again, as I will show you, it improves air quality. This results in reduced chemical usage, reduced water usage, because it does reduce the amount of backwash cycles that you have to perform. Again, that's because it reduces the organic contamination we hypothesize. Reduced energy usage, reduced maintenance, and reduced system wear. How did we decide to look at disinfection byproducts in terms of the use of sphagnum moss? Well, the primary one was as people started to use sphagnum moss in commercial pools indoors, we noticed and we were told about that the chlorine smell, which we all know isn't chlorine, but that smell went away. That was a qualitative reduction, but many people would tell us that, and we would notice that when we walked into some of our early facilities in the Minneapolis area that we're using sphagnum moss in their commercial pools. Once we've learned that we reduced the organic contamination, this started to make sense because we're reducing the substrate for the chlorine to react with. The fact that we reduce and stabilize chlorine levels also probably helps in terms of creation of disinfection byproducts. And then the fact that the stabilized pool chemistry is present also should help reduce the production of disinfection byproducts. But it's probably mainly due to the reduction of organic contamination and the fact that we reduce the chlorine demand and that the use of chlorine goes way down in pools treated with sphagnum moss. Measurement of disinfection byproducts. We use a off-the-shelf method from Hach. I'll talk about that in a minute. The water samples that we collected in brown glass vials. These are certified vials, certified to be clean and non-contaminated. Samples were collected under the water surface and capped under the water surface so that no air was trapped in the vial during sample collection. We took duplicate samples every time we sampled pools and tested those samples. They were stored at 4 degrees centigrade and protected from light until they were measured. Samples were tested within 5 days. Typically, they were tested within 1 to 2 days. There were occasional times where they were taken on a Friday and they weren't done until the next Monday or Tuesday. So sometimes they were a little longer. As I mentioned, the trihalomethane assay is produced by Hach. It's primarily for use in testing it for drinking water. We applied it to this methodology, and it works fine. And we've done lots of work with them to make the assay more suitable for doing swimming pool water. It's a colorimetric assay. It's relatively easy to do with a spectrophotometer and a few other sorted laboratory supplies. The results are expressed as parts per billion, and that's from a chloroform standard curve. Here's what the method actually measures. It measures more than just the trihalomethanes. It measures chloroform and bromoform, and then the other creatures that are formed from that, the dichlorobromomethane and the dibromochloromethane, which are your typical trihalomethanes. Also measures haloacetic acids such as trichloroacetic acid, tribromoacetic acid, and dichlorobromoacetic acid, and dibromochloroacetic acid. Measures acetonitrile, trichloroacetonitrile, and trichloropropionone, which is a ketone, and also chlorohydrate. So it doesn't measure just trihalomethanes. but also all the haloacetic acids, which also have toxicity, as do the ketones. This is a bit of a regression, but I figured it was better to put it here after I talked about how we measured these things. This looks at the disinfection byproduct formation using chlorine and exposing it to organic material. This particular one is a system where we created a Pseudomonas biofilm on glass beads and then ran the chlorine into the column system, let it react with the biofilm, and then collect that sample and look at the disinfection byproducts that were produced. We've also done this with sand filters, material straight out of a sand filter, and get the same sort of results. And it seems intuitively obvious, but if you take biofilm or you take contaminated sand from a sand filter and treat it with chlorine, you get the production of disinfection byproducts. And the reason we have to use such high levels of chlorine is because in this static sort of batch system, the chlorine gets sucked out so quickly that if you put 100 parts per million in there, you'll only recover less than 5 parts per million after 5 minutes. So we heavily overloaded the system with chlorine, but you can see as the chlorine concentration goes up, the disinfection byproduct production goes up as well, indicating that there's plenty of organic matter in those systems because you keep adding chlorine, you keep getting disinfection byproducts. So I think some of you have seen this. This is a study we did almost, I think, 3 years ago now. It was done at a health club in the Minneapolis-St. Paul area that had 2 swimming pools right next to each other. They're in the same natatorium, and they literally are right next to each other. One was a lap pool, one was a leisure pool. They were in a large natatorium with fairly high ceilings, and they got significant bather loads, again, because it was a health club. The leisure pool is primarily children and things of that nature, and the lap pool is primarily adults. And what we did here was, prior to the addition of the sphagnum moss, got some baseline samples of the disinfection byproducts levels. The other thing we did in this pool is we actually measured the air. So we had, with a company that actually measures disinfection byproducts in the air, they sent us these metered canisters. We put 4 of them around the facility, 1 at each end of each pool, and sampled the air in addition to doing the water sampling of for disinfection byproducts. So we did that both before the sphagnum moss product was added, and then for the water samples, which is what you see here, we monitored them pretty much weekly or every other week for about 7-8 months. And for the chloroform measurements that we actually did in the air, we measured those both before the sphagnum moss was added and then at week 28 here, so at about 7-month standpoint out, we did that again. This is like I said, this is the data from the water, looking at disinfection byproducts or trihalomethanes using the assay system. And you can see that the solid line here is the addition of the sphagnum moss. We made 2 measurements of each pool prior to the addition of the sphagnum moss and then monitored them over time, as again, out to about 8 months. And you can see here overall the disinfection byproducts dropped from about 1,600 parts per billion down to roughly the 400 parts per billion range in both pools. It's typical in field studies. Not everything went smoothly. Both of these pools ended up being drained at one point for technical difficulties with mechanics. This one right here got drained, and this one here. But again, interestingly, and I'm not sure why this happened, and it may be my hypothesis is there's crosstalk through the air, but I haven't been able to prove that yet. This pool, after draining, went way down, obviously with the fresh water. It came back up to match the other pool, and then they both kind of went down together. Then this pool got drained, and it kind of came up to approximately the same level. Again, this was good data. It indicated that maybe the sphagnum moss was able to inhibit disinfection byproduct formation. But as I said, It was two pools in one facility, and it had a number of problems during the time frame of the study. So we've gone on now and done other things. But to finish this up, these were the chloroform levels. As I said, we measured chloroform levels both before. This is the mean of the 4 different chambers that the air was sampled into. We sent those off to an independent facility that actually, by GC mass spec, measures the chloroform levels. And the data here shows that before the sphagnum moss, those samples, we did that both 2 days before. The mean was 0.15 milligrams per meter cubed. And at week 28, after the addition of the sphagnum moss, that dropped to 0.067 milligrams per meter cubed, and that's statistically significant at the p.001 level. Subsequent to that, we've gone on and looked at a number of other pools. I'll explain these box plots. They're kind of useful tools to look at to analyze the data. What we've done now is to try to get larger numbers, because every individual pool, like I said, has its own unique features. We went out and got a cohort of pools that we could sample relatively easily within the Minneapolis-St. Paul area, or Wisconsin, or even down in Iowa, where we could get samples relatively easily and get them back to our laboratory. We looked at 34 pools that did not ever have sphagnum moss, and then 22 pools that did have sphagnum moss. Most of these, the UV systems were shut off on. I think in all of these pools, I think there's only 2 pools that still had the UV systems left on throughout this part of the study when these samples were done. And so, by and large, most of these pools do not have UV systems operating at the time. And so what we did is get these samples before the moss went on. And as I'm going to show you in the next slide, we have some paired samples where we got moss from the same pool. We got samples before and after moss. But these are just 2 cohorts of pools that we examined. For the moss treated, we took the data after the moss had been on for 2 months. So it was probably between 2 and 2.5 months we got samples from those pools after the moss had been on to give it time to be active. If you recall from the slide before up here, in about 2 months we were seeing roughly a 50% reduction. So we thought that we should be seeing that when we sampled these pools. And actually we get down to about a 75% reduction here overall if you let it go out long enough. And it did seem to plateau. So it looked like it wasn't going to get any better at that point. So for this study, like I said, we looked at the disinfection byproduct levels after at least 2 months of sphagnum moss treatment. And what you see here is if you look at the untreated pools, these box plots, I'm not sure how many people are familiar with them. I'll just briefly tell you what all this means. This line here is the median value. This is the 25th percentile and the 75th percentile, so 50% of the data resides within this box. This is the 98% level of all the data. These would be considered outliers, the black bars. And then this value here is the mean value of the disinfection byproduct levels, and the same for over here. It's interesting, the data with sphagnum moss pools, and you'll see this on the next slide as well, actually tightens up a little bit, which is kind of interesting too, although we still do have a few outliers. So this data shows us, if we look at the mean values, the mean of the pools that did not have sphagnum moss treatment for disinfection byproducts was about 1,213 parts per billion. And the pools that have at least 2 months of sphagnum moss treatment were at about 730 parts per billion. And using a rank sum test, that was significant at the p.04 level. So that gave us a good indication that the sphagnum moss does decrease disinfection byproduct formation. So we looked at some pools where we did both before and after on the same pool. So we've got 13 pools where we measured the disinfection byproduct levels before the sphagnum moss went on, and then again, between 2 and 2.5 months after the sphagnum moss went on. These numbers are actually part of the earlier numbers, but these are the paired studies. And again, you can see for this cohort of 13 pools, the mean was more like, I'm trying to think here, it was like 943 parts per billion versus the mean of the treated ones was 568. So for this cohort, the overall mean was a little less to start with of the disinfection byproduct levels. But these are paired, so every pool here is also represented here. And again, after 2.5 months, this is statistically significant at the p.017 level, doing a paired t-test. This value drops about 35% in 2 months, whereas the earlier studies with the old cohorts were about 40%, and then the earliest study that you saw was about 50% after that 2-month figure. So about in the same ballpark. So this data would indicate that use of sphagnum moss does definitely reduce disinfection byproduct levels in swimming pools, commercial pools. So results, sphagnum moss treatment reduced disinfection byproducts in commercial swimming pools. It was up to 75% reduction in disinfection byproducts after 7 to 8 months. That correlated also with a 55% reduction of chloroform in the air. We got about a 40% reduction of disinfection byproducts within 2 months with 2 cohorts of swimming pools with and without sphagnum moss. And in the paired study, we got about a 35% reduction in disinfection byproducts in pools, again, after about 2 months of treatment. Why do we think this is? Well, primarily, we think it's because we reduce the organic contamination. And I haven't shown that data here today, but we know that from studies we've done in our laboratory and from pool studies that we've done that we do reduce the organic contamination, primarily in the sand filters of swimming pools and things of that nature, and we also reduce the combined chlorine levels typically in swimming pools. Part of it might also be to the fact that we stabilize the pool chemistry of the whole system, and another significant part of it might be due to the fact that we reduce and stabilize chlorine levels. Most pools that use the sphagnum moss system, because the chlorine levels are so stable, feel they can drop their chlorine levels down a little bit because they don't have to worry about them going beneath the 1 part per million level, which puts them out of compliance. So we recommend even that you drop your pools down to about the 2 parts per million chlorine level. And the other part of that is we know that from all the studies that we've done that we reduce the chlorine demand. Again, that's probably all related to the reduction of organic contamination. I think that is it. Yep. So with that, I'll take any questions.
Can you tell us your name, where you're from, and
What's
your
that?
question?
I'm sorry.
Hello, Steve Dunn, Commercial Pool Systems, San Francisco area.
Yeah.
First thing is there any third-party studies that have been prepared?
About this? About the
sphagnum moss, yeah, third-party studies.
We have done a study that with the University of Maryland, not with disinfection byproducts, but with the rest of these effects that I described, the reduction in backwashing, the reduction in chemical usage, and things of that nature. That's been done at the University of Maryland for the last 3 years. They actually collected all the data and all that stuff and have reviewed all the data, and we are in the process right now. We do have a report on that from 1 year prior to the use of sphagnum moss and 1 year post-use of sphagnum moss. We just completed the 2nd year of post-sphagnum moss usage, and we're preparing that data with the University of Maryland right now.
Okay, another question.
Yep.
Couple questions. First of all, is there a level of chlorine at some point that destroys the sphagnum moss?
Yes. If you go above 5 parts per million, the chlorine will tend to bleach the sphagnum moss. So we recommend that you stay below, well, we don't recommend, we require that you stay below 5 parts per million chlorine.
Okay, and you mentioned that you request that facilities drop their chlorine values down to 2 parts per million.
Correct.
Is that a request or is that a requirement also?
We don't require that, but if you do that, you're going to see a more chemical savings than if you leave them up at 3 or 4 parts per million, depending on the facility. A number of facilities have gone down as low as 1.5 part per million, but we don't require that.
Okay, so if we also drop the chlorine values in the pools, isn't that automatically going to drop the chloramine values as well as the disinfection byproducts?
Yep, absolutely, it should. It should.
So
that's part of the, as I mentioned in the summary here. That's part of the reason we may be seeing the decrease in disinfection byproducts is because there's less chlorine in the system and there's less chlorine demand, so there's less chlorine being pulled out of the system.
So can you differentiate then between?
Not right now. We're in the process of trying to do that, but we haven't been able to differentiate that right now.
Okay.
Yep.
Thank you.
Thanks. Any other questions? Back here.
Erica Taylor, Aquatics International. Mm-hmm. So what do you do if someone needs to shock the pool?
We have 2 methods of delivery of the sphagnum moss to a pool system. One is within the surge tank, so you physically have to remove the moss from the surge tank. The other is through a contact chamber, which is valved, and you just have to turn the valve. So it depends on the system. But the moss is removed from the operation of the flow of the system during shocking.
So if the pool is being serviced by a service technician, that person would then really need to be trained, I'm imagining, on the importance of something like that.
Correct, yes.
Okay,
Yep.
all right, thank you.
Any other questions over here?
Back here in the corner.
Ray Dankowitz from Hayward Pool Products.
Yeah.
You didn't mention the mechanism of action for the removal of the DBPs. I presume you're going to tell me absorption, and if so, could you tell me the absorption capacity of the sphagnum moss for those compounds?
Actually, no, it's not due to absorption. We feel that right now that the mechanism is, as I mentioned here, it's because we reduce the organic contamination, so there's less substrate for the chlorine to react upon. So we don't think we're actually absorbing the product, the disinfection byproduct, the actual product. We feel we're inhibiting the creation of the disinfection byproducts because we're reducing the chlorine, amount of chlorine in the system. We reduce the chlorine demand because we reduce the organic contamination. That's our working hypothesis at this time.
Sorry, follow-up. So the organic contamination is being absorbed?
It's being removed. There's less organic contamination in the system. I have to tread a little lightly because I can't say the biofilm word here, but we know that from lab studies and things of that nature that we reduce organic contamination in the system.
Thank you. We have time for one more question, and the lucky lady is up front.
My name is Stephanie Velagal. I'm a chemical engineer from Penn State.
Okay.
So I had a similar question about the mechanism. I'd
Sure.
be really interested to know about that, but it sounds like you guys aren't maybe so sure what the mechanism is. But then my follow-up question was, since it's an organic sphagnum moss, do you have any insight into why it doesn't impart an organic load to the water?
It probably does to some degree, but we use like gram quantities per 1,000 gallons.
Okay.
And so we don't use I think our standard dosage in a commercial swimming pool is 6 grams of sphagnum moss per 1,000 gallons of water. So it's probably pretty minimal compared to the rest of the organic load in the system.
So in these systems, did you replace the sand filter with the sphagnum moss?
No.
You just put it in addition
it's an add-on.
to.
We don't take anything off the pool systems whatsoever.
So you have the sand filter, then the sphagnum moss.
Correct. Yes.
So you're somehow are reducing the organic load from the sand filter. Right.
The sphagnum moss has compounds in it that reduce organic contamination, that are released from the sphagnum moss. We've done those studies in the laboratory, and then, like I say, we've always also correlated them to field studies where we've looked at the contamination in the sand filters and see that it is reduced.
Okay, thanks. That's great.
So please join me in thanking Mr. Fiegel for his time
Thank
today.
you.